Hello class, welcome to our lesson today dealing with section 5.3. This is dealing with binomial probability distributions. We actually have been looking a little bit about that when we did probability distributions with the tossing of the coin with tails and heads. So we're going to go into more detail with that today and go ahead and get started with that, using the rules and procedures that have to be followed in order to be a probability distribution that is binomial. First off, you have to have a fixed number of trials in your procedure. Okay, so like for example, tossing the coin so many times, things like that. Each trial must be independent, so it kind of has to be with replacement, or like a tossing of a coin. The first toss doesn't affect the second one. There can only be two categories, which is where the binomial idea comes into play. We only call a success or a failure. Now, what you don't want to get into the habit of is like the tossing of a coin. Well, what if it lands on the side or things like that? Well, that would be a retoss or things like that. And then the probability of success needs to be the same for all trials. So again, the tossing of the coin or rolling of a die are good examples of that. Whenever we are looking at sample sizes, if the sample size that we're taking is a very small group compared to the whole population, for example, if I want to look at 100 people versus the population of the United States, we can treat those selections as being independent, and so that would allow us to do the binomial distribution, even if it's a without replacement. Something similar to that would be like the tire question from your homework the other week where you had 100 tires. We treated those as if they were independent, and we didn't have to worry about using the dependency of going down by one in the numerator and denominator. Notation-wise, success is S and F is failure, but probably more important is this P and Q. So P is the probability of success, and Q is 1 minus that, which is the probability of failure. We'll be using P and Q almost exclusively as we move through the unit. So you want to make sure that you use that same notation because that's what your book's going to use and that's what I'm going to use as we go through this. N is the number of trials. So if I toss a coin 10 times, then N is 10. And then X is the amount of trials that have those, the amount of successes of those trials. So if I want to say toss the coin 10 times and I want 3 tosses to be tails, then X would be 3. The probability of that would be P of X. And again, this is similar to what we kind of had before. We're just putting a larger twist on the binomial aspect as opposed to the first ones, which were just probability distributions in general. Okay, so here's back to our 70% chance of getting a tails. X is the number of tosses that are tails. First off, does this fit a binomial distribution? The answer is yes. There's the same amount of, or probability of success is the same every time. Fixed number of trials, independent. And we have P and Q. So in this case, if I toss it 5 times, that's N. X is the number of tails, so that'll be different depending on the question. Probability of getting a tails with success here would be 70% or 0.7. Probability of failure would be 0.3. And those two should always add to 1. Okay, there's 3 basic ways you're going to be able to find some probabilities based upon these random variables for binomial distributions. The first is a formula, and it's a binomial distribution formula. This is the one you need to understand for the test. You're going to have to be able to show this. You're going to have to be able to explain it. You're going to have to be able to write it out. And notice here, all it is, this first part is a combination of n choose x. So n choose x, then times p raised to the x power, and q raised to the n minus x power. And that would be how you find it for each probability. You're going to want to know this one really well. The one I circled is the version that I would expect you to be able to write out, and then be able to plug it into your calculator to find the answer. The second one is a table in your textbook. It's Appendix A, Table A1 in your book. It's not used very often because it has to have specific P and Q values to be able to be successful. You might see some questions say use the table to find the answer. You could use the table. You could also use this formula. So either way would be okay. The third option is to use binomial calculators from StatCrunch. That idea will be helpful some on your homework. I caution to use that exclusively, though, because on your test you're going to have to be able to explain and show your work about how to get those answers. But it could help a little bit if you're looking at this situation. And you go to Stat, Calculator, Binomial. You'll plug in N, plug in P, and then you'll decide what you want. Do you want X equals 3? Do you want X less than 3? Some of the questions that are more in the middle for your homework might use this idea, and it might be a lot faster to find. I'm going to try to limit that a little bit on your test questions just because of the limitation of plugging into your calculator anyway. Okay, so this is the table that I gave you in section 5.2. I'm just going to show you how to find one of these numbers. So I decided to do P of 2. So X is 2. So that'd be 2 tosses or tails. So N is 5 tosses. X is 2. Probability of success 0.7, probability of failure is 0.3. So I do a combination of 5 choose 2 for the n and x, and then it would be 0.7 raised to the x power, which would be to the second, and then q, which is 0.3 raised to the third power, because 2 plus the 3 should be 5 total tosses. And I plug all that in, I get 0.1323, and I round this to 3 decimal places. The reason we're rounding to 3 decimal places is typically all your textbook questions will be rounding to 3 decimal places as well. So I'm going to try to be consistent on that. And if the book may tell you, or the homework and book may tell you to round differently depending on the question, but in general, I'm going to go 3 places. I would make sure to plug that into your calculator to make sure that you can get an answer that makes sense. This question here says to find the mean. Okay, remember, to find the mean, you take x times p of x plus x times p of x and go through that. I would encourage everyone to try that out to make sure you can find the average or the mean by hand. If you are asked to find the standard deviation, you would be able to use StatCrunch to be able to find that, and that's under Stat Custom, and you want L1 and L2. Those are the pieces you want. You want to type in L1 for the first group and then by L2, and that should help you find that second answer. Some other homework questions that you'll see deal with expected values. So this is a pick 5 lottery game. Okay, so there's 10 to the 5th power number of selections, because 10 times itself 5 times, because the numbers can repeat themselves. The probability that you win would be 1 out of 10,000. Now all of that is just based on the fact that it's a pick 5 game. If you win, what's your profit? Well, if you collect this 42,000 number, you got to subtract the 75 cents that you spent. So this 42,000 number minus 75 cents, $42,153.25 would be your net profit. And then probably the most important is the expected value. So to find the expected value, you would take the probability you win, which is 1 out of 10,000, times, 1 out of 100,000. I miswrote this one here. So the probability you win should be 1 out of 100,000. I just noticed that. So it's 1 out of 100,000 times how much you win, which would be the number over here on the left, plus probability you lose, which would be 99,999 over 100,000 times negative 75 cents. Don't forget it should be negative because you would lose the money. And then that would give me a negative 33 cents final value, and that's what I should expect to lose. Now technically this was negative 32 and like 8/10 of a cent. So if I'm comparing to this other game, they're about the same. They're both losing 33 cents. You might pick one over the other. It kind of depends on what you're looking at, but they're pretty close at that point. Technically, this first one, New Jersey, is a little bit better because it's a little bit closer to 0. But in general, it's pretty close at that point to be the same. Okay, that was a lot of different information about binomial distributions. Remember, the most important thing is that on a test situation, you're going to have to be able to use this formula in order to be successful and show your work. The table could be used some, and then StatCrunch using Stat Calculator Binomial instead of Stat Calculator Custom. Okay, Stat Calculator Custom can give you the mean and standard deviation of any table. The Binomial, though, can give you the probabilities very quickly. In general, though, you want to make sure you have this formula figured out. Make sure you start on some of your homework early, because you want to make sure that you have the ideas ironed out earlier than later as you're looking at some of those scenarios. Have a good day, everyone.